Hi, Nazneen.
Yeah, we would like to give you a small introduction about Techcanvass before starting the session. We Techcanvass are into ID certification training. We are authorized training partner with IIBA Canada and ISQI Germany. We have entry and senior level certification program for IIBA as well as Agile Business Analysis certification for ISQI. We are also authorized to conduct training for CPSET for Selenium training. Please do visit our website for any query. And let me introduce you to our trainer, our speaker for today, Mr. Arimitra. He has been associated with analytics industry for more than 8 years, with overall 9 years of experience. He has specialized in statistics and worked primarily with SAS, R, and SPS and Excel to solve business problems. And currently he is employed with an MNC company. Good morning, sir. Over to you. You can start with this session for today, which topic is data visualization with GGPlot webinar. Thank you so much, sir.
Thank you, Nazneen. Hi, everyone. Good morning. Thank you so much for joining today. And it's really early morning on Sunday. So let me just share the screen and let me know if all of you can see it. I'll just try and put it in the slideshow mode. Okay. So before I start, I'll not be able to look at the chat window because I'm sharing the presentation on full screen. So if anybody has any question, please do stop me immediately so that the doubts get cleared and we uh, absorb the concepts as is, and then we make ourselves available to improvise on those concepts. Okay, so this is today's agenda that we are going to discuss today. We will start off with a short introduction and then a takeaway of what we want to infer from today's discussion. We also going to talk about what is data visualization and the basics of GGPlot visualization. And from slide 7 onwards, we will specifically move on to the nitty-gritties of this GGPlot in Revolution R. And finally, from slide 27 to slide 34, which you look at the very last row of the agenda table, we will going to pick up a case study from a free available data set and see if we can use the GGPlot functions and figure out whether it helps us or not. So quickly move on to the introduction here. So today's webinar is basically, I wanted to highlight the impact of data visualization on the analytics industry or on any industry where some amount of data crunching or analysis is required. However, since we would need a tool to undergo that data visualization, I thought let's pick up Revolution R. And within Revolution R, of course, we have basic methods of plotting. The charts, the pie charts, the box plots, the line charts. However, the chief data scientist, Hadley Wickham, who has been reinventing Revolution R since 2010-11, he has developed this package, which is known as GGPlot. It's available once you install R. You just need to type in install.packages and then put in the package name GGPlot. It will install in your directory, and then you can use the library or require command to load it up. So Chief Scientist Hadley Wickham has been developing a lot of packages for which have been put in use today, and they are widely getting used and popularizing the power and the strength of Revolution R. It was not like that at least 10, 12 years ago. It was a market monopoly for SAS and SPSS. But Chief Data Scientist Hadley Wickham has introduced packages like TidyR, dplyr, Plyer, GGPlot, a lot of useful packages that we use today for data visualization, data extraction, manipulation, and as well as statistical analysis. So Revolution R is a very powerful tool for using the data visualization stuff. So today's webinar will purely focus on this particular package and talk about how quickly you can leverage all the functions of or rather most of the functions to infer a particular business problem. Okay, so what are the few things that we want to take away from today's discussion? We want to know how we can quickly use a scatter plot using 2 and 3 variables, how to effectively use the smoothing functions along the point function, how we can use normal bar plot, line plot, histograms, what exactly we have in the binning method, and how quickly I can apply those methods in the form of a particular case study. Not necessarily predictive, but descriptive would be fair enough to understand the power of data visualization. Once we can structure what we want to do, obviously we can take most of the inferences out of that data set. So I would request if anybody is not speaking to go on mute, because there's a lot of background noise which may affect others to understand what exactly is going on, and also the voice modulation would be a little different. So thank you for understanding and your cooperation. This is a brief takeaway of what we can take from today's discussion. But again, if you have any question at any point of time, please do unmute yourself and please let us know the questions. It will not only help you once you get the answer, it may help the entire audience today, and it can help me as well to understand more on the concepts. So I'll quickly move on. What exactly is data visualization? So data is something which is a set of numbers or text or some records that gets recorded in a particular platform. It can be an Excel sheet, it can be a data frame, it can be a data set, it can be a table, it can be an SQL architecture. So we know already about data, but what exactly is visualization? So let's go back to our school days when we used to read the books in any subject. So I don't recollect a book which has not been put together without a picture. So every chapter I recollect, I mean, not necessarily line by line, but I don't recollect a subject which used to talk about a particular concept without a picture. Not every concept line by line, but the overall view definitely used to get depicted by a picture. So people believe, or human believe, that visual memory is more powerful than a reading memory or something which you know on your own. Okay, because eyes can remember more than what you write on a piece of paper. So back in our school days, we used to use a lot of graph paper to draw the line charts, to draw the frequency charts, or we used to do a lot of diagrams in any kind of subject, be it physics, be it biology, or even in geography. We used to make a topographical sheet where we used to make a short distance map of a stuff which used to use a dimensional scaling. I remember. So that's all part of visualization. Basically, the whole intent of talking about this is visualization is nothing new in our life. Visualization is nothing new in the IT industry or in the analytics industry or in the corporate business or in any business to talk about. Every business uses visualization. Without visualization, humans cannot work. It's the only difference is, as we go on, as we move on, there are different tools that we get. We need to know how we need to use those tools and how we need to interpret our ideas that we know, that we have been reading till now, how we need to communicate through that language, put our thoughts into that language, and make sure that language gives us back that same visualization we are dreaming in our minds. That's all. I know somebody might have done that visualization in Visual Basic, somebody might have done it in plain Microsoft Excel, somebody might have done in PowerPoint, which we are doing today, again, is a part of visualization. So it is nothing new. So visualization has been a key member in all different industries, especially social media, especially politics, especially any kind of business, the major driving business in the world that gets driven rather by visualization. Okay, so I won't go line by line on these traditional definition, but what I wanted to give an essence to the audience today, that don't take a back step of while hearing the word data visualization. Please don't take a back step while you hear about Tableau, ClickView, or Revolution R. These things are nothing but a language that we need to speak, that we know how we need to speak. And once we know how we need to speak, why we need to speak, one thing we can be sure of is that our language needs to be communicated in a way. If it gets communicated in a proper way, the other end will throw us back what we are planning in our brain, what we are planning to do. That's all. It's just a medium of communicating with the computer. Okay. So quickly, what exactly is visualization using the GGPlot way? Now, quickly talking about the advantages, apart from the basic plotting methods that R has, GGPlot uses a consistent, underlying grammar of graphics. Now, what exactly grammar of graphics? We will talk about that very shortly. It has got different layers on which this entire GGPlot package is distributed into. We can plot specific things at a very high level of abstraction. Very flexible theme system, mature and complete graphic system. Many users have been using it for a very, very long time since its evolution. And it can also be, fed as an active mailing list where you can directly create the charts and mail it to the users. Just like other tools, this is a very common functionality which SAS has or Tableau has. The basic idea of GGPlot is, independent. It's independent of any work that you do in R. Okay. When R got invented by the scientists of New Zealand, they created certain functions which cannot be modified. Okay. The outputs that were coming out of Revolution R, those were pictures which cannot be modified. Now, Hadley Wickham created this package, GGPlot, which allows users to create plots as an object. You can modify that object and do whatever you need to do at your subsequent steps and make sure you can keep on modifying them until you are satisfied, which you cannot do in our basic plotting functions. Okay, so this is one of the biggest advantages which GGPlot provides compared to other packages, and this is one of the most driving feature of GGPlot, why it's because of which it makes available in such a in such a great scale of use to the users. Okay, unless you are able to modify those plotting functions or those work that you are, those coding, little bits and pieces of coding that you're doing, if you cannot modify them, it's of no use. You have to write that all long piece of code until you're satisfied, remember everything in your brain, and the output comes out as a picture. That becomes really difficult. So GGPlot 2 addresses that difficulty and allows user to create and modify charts, labels, backgrounds, everything, even statistics within the chart as an object. You can modify each and everything until you're satisfied. So there are different building blocks of GGPlot 2. First, you need to feed in the data. You need to know about what is aesthetics, what is the geometry in GGPlot, what are the statistical transformation, how do you modify the scales, the coordinate systems, the position adjustments, the faceting. Now, these are very technical terms. All of this, or rather most of this, we have a time limitation as well. Most of this have been addressed in the PowerPoint. However, if you think there are, most of the very common things have been fed into this presentation, but however, this is not complete. I really, really encourage you to go and search the facts on the internet, do it yourself, practice it after the webinar, and I'm sure you will find the essence of GGPlot 2 like others. Okay, so let's move on to what is grammar of graphics. Now, grammar of graphics was first described by Dr. Leland Wilkinson. There is a book written by Dr. Leland Wilkinson where he talked about the grammar of graphic system. It's available on the internet. I don't know if there is a free version available, but Dr. Leland Wilkinson was the first person to talk about the grammar of graphics. Based on this concept, grammar of graphics, Hadley Wickham built this package. However, although Dr. Leland Wilkinson invented it, but it was rather spread across to the entire universe by Dr. Rick Scavetta. Rick Scavetta is a very well-known person who has been teaching about ggplot 2 functions on several platforms. His book is available on the internet. There are a lot of free materials available by Dr. Rick Scavetta. And he also is a part of leading training material, leading training portal. So you can follow the works of Dr. Rick Scavetta as well as Hadley Wickham. And of course, if you come across the book of Leland Wilkinson, please do read it, because what I learned myself, it's not because of the actual free materials, but I followed these three people who have helped me to learn what I'm discussing with you today. So these are all each row on the table that you see is a layer of the ggplot function. First, you feed in the data. So the data that needs to be plotted, the data would have variables of interest to choose data argument. Next comes the aesthetics part, the scales used to map our data. How you use the aesthetics, you will see very shortly, right on the next slide. So aesthetics is nothing but x-axis and the y-axis, how you define the axis, which variable goes into which axis, how you define the color, how you define the diameter of the points, the fill size, the labels, alpha, line width, all of this we will talk about very shortly. What is alpha, what is line width, what is line type. If you are completely new to this, so don't take a back step. I'm sure you have done it somewhere, somehow, in a different platform, but maybe not in the same platform. Even if you have done it on the same platform, it would be a good idea to revise ourselves. So what is geometry? The visual elements used to plot our data. It is nothing but all these functions we can use along with the base data and aesthetics layer to get what we want. These are all additional functions that has been highlighted in geometries to draw exactly the thing that you want. So point goes for a scatter plot, bar goes for a bar plot, line goes for a line plot, histogram goes for a histogram, box plot goes for a box plot, and there are many other things. These are the most common plots that we use in a common day-to-day function. But of course, there are different things as well. You can use them based on your need and purpose. So geom is nothing but the geometry. It's a short form of geometry. It's this, but each function allows you to impose that specific type of chart onto the data and the aesthetics part that you put across. Okay, so data, then it sits the aesthetics, on top sits the geometry, then on top of the geometry you have the facet layer. Facet layer you may or may not use every time depending on the necessity. Facet is nothing but you have a method of dividing the charts by a grid system, by row or by column, so that it looks more visible, more interpretable. Okay, you have the statistics function like smoothing, descriptive. You can draw a smooth line, the best fit regression line, which we will talk about today. We have read that in books maybe somewhere, but we can easily draw a best fit regression line depending on the points or the data points that we have in our data set. Next comes the coordinate system. It's not too much that we use in our day-to-day function, but if there is a need to flip the coordinates, like normally it is fixed by default, but if we want to limit the coordinates, if we want to flip the coordinates, we can definitely use that. Next comes the themes. Themes is nothing but anything that is not related to the data is theme. Anything that is not related to the data. Okay, that's why I say all non-data ink. Anything that is not related to the data is theme. What is not related to the data? The color of the line, the color of the background, the appearance of the background, the appearance of the, the grid where the plotting is happening, the font, the header of the label, of the axes, of the exact data points that gets plotted on the x-axis and y-axis, all those that's not related to the data, all the aesthetics part, all the things that we used to modify with a sketch pen in our school days, back in our school days, we used to make the things bold, italics, then different font, everything that is not related to the data belongs to theme. Okay. Now, aesthetics, please do keep in mind, this is one of the most important stuff that we will use in GGPlot. X-axis, Y-axis, this function needs to know. Other than that, it's very difficult for this function. You don't really need to mention what is x-axis, what is y-axis all the time, but by default, x and y, x comes first and then comes y. If you know the order, it becomes easy to map the data. Okay, so quickly move on to this slide, how GeoPoint treats x-axis. So each slide would have the code corresponding, which have been used to plot the data. The data set is available the moment you download the package. This is a free data set. I'm not using it. I'm not modifying anything on this data set. The moment you download the package, the data set also is available. You can try it on your system and see how it looks on your system. But to understand the concept, look at how the first chart is being made. GGPlot, that's the data and the aesthetics part. The data is the empty cards data set that we're using. The aesthetics, which is a short form of AES, that begins with the first bracket. Within the first bracket, we always need to mention X followed by the Y. Okay, so always remember the X comes first, the Y comes second, no matter what GGPlot functions we are using, no matter what geometries we are using. We can also use the aesthetics inside specific geom functions. However, just to understand the initial part, this is how the function gets built. The aesthetics comes next to the data, and once the aesthetics and data are defined, we wrap data and aesthetics inside the GGPlot and then add a plus sign to add the specific scatter plot. So I wanted a scatter plot out of this data. I'm adding a GeoPoint function. Okay, but by default, see that cylinder is a numeric data. Okay, cylinder, if you look at the data set structure, cylinder is a numeric data. So that's why you see on the first plot, you have 5 in between 4 and 6. I don't know how big it looks on your screen. I really apologize if it's too small, if you have any vision problem, but that's the best I could fit these charts. So 5 comes in between 4 and 6, 7 comes in between 6 and 8. So you see extra data points have been plotted. So that's because GGPlot by default treats a numeric scale, and on the X, if you are putting the numeric scale, which I have put X as cylinder, by default it will plot it in a numeric method. But if you don't want the unwanted numbers, you have to convert it into a factor, which you see on the second graph. I have used a factor function. What exactly the factor function is doing? It is saying that there are only 3 levels in the data, 4, 6, and 8. We don't need any other unnecessary numerical levels like 5 and 7, so that we only need to see 4, 6, and 8 in the chart. We don't want to see the other numbers. So factor converts distinct levels in the data and helps you to plot in a chart or in a data frame, in a table. That's all. So the intent of this chart is to see that by default, GGPlot will treat a numerical variable on the x-axis. If you're plotting a numerical variable on the x-axis, by default, all the numbers will get plotted from the minimum to the maximum. But if you don't want the unwanted numbers, please do use a factor function wrapped around that particular variable, and it would be able to negate that difficulty. Okay, so that's why I said this time x-axis shows only the values of cylinder that are present in the data. Next, how can you use size argument inside the aesthetic to a third variable? So see, the x-axis remains the same, okay? I'm using a weight x-axis. On the y-axis, we have miles per gallon, okay? Both are numeric. This time I didn't necessarily use the factor function because those are the distinct values, 2 to 5. The minimum value starts from 0. The maximum ends at, I think, 6.5 or 7, somewhere around that. If you want, you can definitely use it, but weight is an interval scale, so there is no point in using a factor method. It will automatically reduce the data. So on the x-axis, you have weight. On the y-axis, you have miles per gallon. But along with that, I wanted to see the relationship of a third variable, which is display. Display is nothing but the display of each car. So what is empty cars data set? Each row is a car, and each row has different attributes of the car. Okay, the engine size, the miles per gallon, the weight of the car, the display size of the car, the different attributes of the car it talks about. So I want to know how weight and miles per gallon relates to each other, but also along with display. So you can see on the first chart, I have small dots appearing based on the color of the display. So since display is a numeric variable, you can see the blue line across that starts from 100 to 400, and the shades keeps changing as the number increases from 100 to 400. But let's say I don't want it this way. I want to change the diameter of each point should change along with the levels of display. So that's why instead of color, in the second chart, I've used size. Okay, so as the value of display increases, the size of the diameter also increases. So from the second chart, you can clearly infer that instead of using color, if you use size, so this is the way permutation and combination you need to do. What's the best way to interpret the data? GGPlot is very useful in interpreting the data rather than giving it a very flashy, cosmetic look. So on the x-axis, you see for the maximum weight, you have the maximum display. So if the weight is also high, display is also high. It directly correlates with the weight and the display, but not necessarily with the miles per gallon. So if you see the highlighted areas, those areas have maximum weight and maximum display. Okay, whereas if you move to the exactly diagonally opposite thing, the weight is minimum, the display is also minimum, whereas the miles per gallon is very high. So there is an inverse proportional method of miles per gallon to display. That's a very high level overview, but definitely the actual coefficients of correlation can talk about it once you try to find that out. Okay, so this is how you can play around the size and color variable. Previous slide talked about how you can use the basic functions, but the next slide talks about how you can also use different methods of aesthetics. So color argument, size argument, these are all part of aesthetics, which you can use inside the aesthetics function. Okay. Next, how we can use a best fit regression line. You see that I'm using a different data set. I again use the x-axis, the y-axis, but along with geom point, I have also used a geom smooth function. It is nothing but it use a method. You can explicitly mention linear method, or you can explicitly mention maximum likelihood method, LOESS. So there are different methods of plotting the best line, but the by default is LM, which is a linear method. It will use best fit regression line across all those scatter points that you have. Okay, so based on depending on your study, if you have a training data set or a testing data set, you can always use a scatter plot function or a smooth function to understand where exactly the best fit regression line runs or passes through. Okay, Now, although it looks very simple here to use the geom smooth function just by using a plus sign and geom underscore smooth function, it's very easy that we have got the best fit line. But if you want to replicate the same thing in any other function, through the basic plot functions, it takes lines and lines of code, lines and lines of iterations. Okay. So this is a very handy tool that we have. So initially it may look that how come such a single function is giving us such a beautiful best fit regression line, but plotting the same thing in base R is very, very difficult. I'm not discouraging anyone if they want to plot through base R, but I'm just sharing my experience. This is how we can texture the color of the line as well. So you have different groups of clarity. On the x-axis, you have the carat of the diamond. On the y-axis, you have the price of the diamond. But each line also talks about the clarity. So you can see that the line that runs, the very long line that runs from 0 to diagonally to all the way, I think that's S1. So any clarity that's been categorized with S1, for that clarity, we have all sorts of carats ranging from low to high price. But if you look at the clarity, which is IF, that ends with a carat of 2.5 and their price ranges from 0 to around 20,000. Okay, so these are the various different ways of identifying the structure of your data, the content of your data, the characteristics of your data. Now, geom smooth function, it will draw a best fit line, but geom point, what does the geom alpha does in the geom point function? Alpha is nothing but it ranges from 0 to 1. 1 being absolutely dark, okay, 0 being transparent. Okay, it's the range of transparence and opaque that you can plot in the chart. So if you see 0.4, you can see the texture of these colors, the scatter plots, have become slightly blurry. You can use it to understand if they are lying on top of each other. So you can see the green color sits on top of the blue. So it's not necessarily, you can infer that there is no data point. So obviously there is data point, but you can vary the alpha figure to identify whether there is actual data inside it or not. So alpha is nothing but the range of transparency to opaque. You can vary the shade color, not exactly the color, but the shade of the color through alpha. Okay. Next, some more examples of geom point and geom smooth combinations. So geom smooth always runs with geom point. Please keep this in mind. Geom point is nothing but a modification of scatter plot. For using scatter plot, you use geom point. Alpha is equal to 0.2. That means I want a very very opaque stuff. 1 means it will keep on making it blurry. That's it. So this is how you can see. So the next example, you can see that I'm using geom smooth, and within geom smooth, you have AES color is equal to clarity. So what basically it does is on the first aesthetic function, I'm using what is the x-axis and the y-axis. On the second geom point, I'm using the texture of the point. But in the geom smooth, I am deliberately mentioning the color is equal to clarity so that the color of the best fit line sits on top of the actual scatter plots, which didn't happen in the first plot, okay? Which didn't happen here, okay? The smooth did lie on top of the geom point, but there are areas which becomes indistinct if you don't mention the AES function inside the geom smooth. So this method is a bit more clarified method. The lines the lines of the color would sit on top of the actual scatter plots, so that it's just like a graph paper that you draw in your school days. You first put the dots on your graph paper and then you draw the best fit regression line which runs on top of those points, so that it becomes very clearly evident where exactly that line is originating from and what's the direction of that line. So you can also use AES function inside other geometrical functions, but this particular example I wanted to give, that if you have a set of points, you can draw a line on top of those points as well by using the AES function. Okay, the next comes, so this is a very practical example. The code lies below the chart actually. So this is an iris data set. This is also a free data set. If you look at the iris data set from your console, you will find that it has 4 variables. It has got 2 kinds of length, which is, somebody has a question. Did somebody has a question? I don't know. Shall I move on, or somebody went on mute? So okay. So we have the iris data set. You will notice that you have 2 different kinds of length and 2 different kinds of width. Okay. Now it's very difficult on a 2-dimensional architecture to figure out how you will plot or how you will identify the length and the width of both the petals and the sepals. Okay, so if you use the basic method of GGPlot, you will see that the iris dataset goes in the data section. In the AES section, I'm using the sepal length and the sepal width. That's why the axes get labeled as sepal length and the sepal width. On top of it, I'm using a geopoint function, which is a scatter plot, the relationship between the length and the width of the sepals. What next I'm doing is I'm again using a point function to identify, or rather to explicitly mention, what is petal length and what is petal width, and put that, or rather color those dots as red. So you see that whatever red dots, those are the characteristics of the petals, but the black dots, those are the characteristics of the sepals. But you don't have any method to put the label as sepal length. You can obviously explicitly mention that the x-axis is sepal length and petal length. You can also mention sepal width and petal width, but you cannot put a legend here because it's very difficult that you are plotting all the 4 variables and then trying to identify the relation. So this is a very good example of how to structure your data. Okay, how am I structuring the data to identify what exactly I want? So what exactly I want from this example? This is not the chart that I want to know. What I want to know is how the length and width varies across all the species of flowers that goes inside the iris data set. I want to know the sepal, I want length, I want to know the petal length, as well as the same for width as well. And I'm also, this method doesn't allow me to bifurcate across the species. It only bifurcating across the variables that's there in the data. So this is a very good method of using the tidyr package. The actual code to create that dataset has been put in the notes section. This is also readily available on the internet as well. But look at what's the intent of the chart. The first chart, this is faceting, okay? On one chart, I'm bifurcating 2. The first chart talks about the length, the second about the width. On each x-axis, you have the species, Setosa, versicolor, and virginica. On the y-axis, you have the value. So you can clearly distinguish that the red color belongs to the petal, the blue color belongs to the sepal. Whereas length is considered, the length of setosa, the petal length for setosa is lower than the sepal length. And that holds true for versicolor and virginica. Whereas the width, the petal width of setosa is lesser than the sepal width of petosa. And that also holds true for all the three species. But the only breaking difference is the length, both the sepal length and the petal length, the sepal width and the petal. I would say sepal and the length of sepals and petals are distinctively higher for virginica, but for when it comes to width, the sepal width and the petal width, they are almost similar to versicolor. Okay, so as you see that you can clearly distinguish, you can derive more characteristics of your scatter plot, you can do more of your data analysis by simply using the TidyR package. How I'm using the TidyR package, that's absolutely mentioned in the note section of this slide. But the code that sits on top, just below the chart, is the actual code that is required to build the chart. But behind this chart, there also goes a data set, which is iris new. Okay, how to create the iris new, you can know from the slide. Okay, so this is one way of identifying scatter plot. Next is adjusting the diameter, the shape, and the texture. You have, you can use the shape, the size, the alpha together to characterize the diameter of the plot, the texture of the plots, the actual point that gets plotted, mind you, not anything that is non-data is the theme, but anything related to the data is actually needs to go inside the geometrical or aesthetic function. So shape is equal to 1 means the diameter of the point that you see. Whereas shape is equal to 16 means see the diameter of the point has actually increased. Size is equal to 4 means the actual size of the points. It not necessarily the diameter, but shape would give you a circle, whereas the size would give you the actual diameter. Okay, you can keep trying different shapes, but along with the shape and size, you can keep varying them. You can create triangle, you can create boxes, you can try all sorts of things. So shape and size together give you a different little feel. So shape and size go together. Okay, alpha is also, as I talked about, used to derive the texture as well. Okay, next slide is adjusting the diameter and shape. Again, a different example of shape and size along with the alpha. You can keep varying the color argument to see how it looks. So if you just use shape 1 and size is equal to 4, you have small, a little bit difficult to read the points, but you can also increase the size and the shape. The points become a little more visible. Okay. Next is you can manually mention the color as well. So you can see that I have used label argument with an O. You can, instead of O, you can put any letter as well, A to Z, whatever you want. So the points that you see on the second plot is nothing but the alphabet O. So instead of O, you can type A, X, Y, anything. Those characters will be plotted. You can also mention an explicit color argument inside the geometric functions to change the color. If you don't like the actual default color. So on the first chart, you see shape is equal to 15. Actually, I think has given square points, data points. It becomes very small. But if you really go inside, shape is equal to 15 is a square structure. All the points would look like a square. But if you explicitly mention the label argument inside the geom text, you can plot anything that you want. Next is the jittery function and the position jitter function. This is a very important concept while plotting scatter plots. If you see by default, you use geom jitter. The x-axis has 4, 6, and 8, but the points are scattered. Okay, but you want the points to be a little bit distributed, so you can use a position jitter. Width is equal to argument. Position jitter width is nothing but reducing the width of the axis that it takes. So on the first chart, the points are taking a lot of space to get plotted, whereas if you use position jitter, the actual geometry or the dimension gets reduced, but the actual data values doesn't change. The relationship doesn't change, the actual data values doesn't change. It's just the structure of the plotting that gets changed. It becomes visibly more attractive. So position jitter is a very useful and common argument that gets used in day-to-day scatter plots. If you have, in the second chart you have 4, 6, and 8, it's easily readable. But if you have more than 4, 5, or 10 data points, position jitter is a good method to use so that one data point doesn't overlap with each other. So the actual code has been given on every slide. You can keep practicing it in your leisure time. Next comes the histogram. One of the easiest way to plot the histogram in R. You just need to mention the histogram, and obviously histogram takes only one axis. So that's why the x-axis comes first. Using miles per gallon. You can use the weight as well. Bin width is nothing but each bin will have a width of 1. So that means you see in the first chart, the x-axis, the bar starts from 10. However, if you look at the actual data, there are values for miles per gallon which are below 10. So when I'm saying bin width is equal to 1, I'm saying keep the bin width as 1 so that it becomes 10 to 11, 11 to 12, 12 to 13, 13 to 14, that way. Okay? So you can keep playing with the bin width and see how the histogram gets plotted. This is nothing but changing the color of the histogram based on the cylinder variable. So you are actually measuring miles per gallon and the count of the frequencies on the miles per gallon, but also you want to plot the cylinder. You want to see how the relationship goes with cylinder. So you can see if the cylinder is 4, is of size 4, then the miles per gallon is very high. Whereas if the cylinder is of 8, then the miles per gallon ends somewhere around 18, which is obvious, because if the cylinder size is high, then obviously the mileage will be less. If the cylinder size is low, the mileage will be very high. The next plot is a freak poly plot. It is nothing but a replacement of histogram. Instead of bar, you can use a line or a density stuff to use. The y-axis, every y-axis uses count, but you can also use the density on the y-axis as well. Now, what is density? Instead of count, it is nothing but a cumulative percentage. You can, Google yourself so that you know more about density and count. You can use freak poly as a replacement of histogram if it becomes appealing to you. Next is the bar chart, the most commonly used bar chart. The default of GGPlot is a stacking method, which you see on the first plot. The second is a dodging method. You need to explicitly mention the dodging method. Again, the structure of using geombar, data, aesthetics, x-axis, y-axis remains same across all functions, no change at all. It's just that you cannot use a position inside geom point unless you use position jitter. But if you are using a bar, you need to explicitly mention the position of the bar. How it will plot the bar? Will it be stacked, which is by default? If you don't mention anything in the first chart, it uses a stack chart. But if you want split charts, split bars, you need to use the dodge function as well. If you mention position is equal to dodge, the plotting will happen this way, which is a traditional Excel method. Of course, you can use the stack as well in Excel. Everything you can do in Excel, but I think the default one gives dodging method. So again, these are a few more examples. You can also position in the second plot here, you can also position the layering of the bars just to make it more attractive by using the position dodge. Just like geometry in scatter plot, we have used position jitter. In bar, you can use position dodge just to modify the aesthetic, the look and feel of the bar. So obviously, the second plot in this chart is less attractive than the second plot in this chart. So it depends on how your taste is, how your data is distributed. So these are all the examples. This is an example of geom line. Again, the method of using the data frame, the x-axis, y-axis remains absolutely same. No change in that. You just need to keep hovering around whether you need a line function, whether you need a bar function, whether you need a scatter plot, what exactly you want to plot. Based on that, define your function and keep plotting the data. This is, way easier, way faster than the basic methods that we have now. No comparison to that. It has been tested through, processing time as well as plotting time, everything way faster than the base R functions. This is again a combination of geom point and stat smooth. You can use the coloring function as well to bifurcate the best fit regression line for each categories. So the first chart talks about how each category of cylinder fits in miles per gallon and weight relationship. Whereas the second plot talks about definitely the individual categories, but also an overall line. That's why I'm using the group is equal to 1. The group is equal to 1, it will actually plot the overall line diagonally. The big blue line that runs across, diagonally, that's group is equal to 1. That plots the actual overall relationship irrespective of the category's cylinder. Whereas the 3 plots together, individual plots, those belong to individual cylinders. Okay. Next is the gridding system. This is very useful. You saw that in the IRIS dataset. But again, if you have a variable which you can, the AM is a variable where I need to see the relationship. So AM, it goes from 0 to 1. So in the first chart, I'm using AM, whereas it is faceting on the column wise. So dot tilde sign followed by the variable name will split the chart column wise, whereas the opposite, whereas you mentioned the variable followed by the tilde and the dot sign will do the faceting row wise. So again, if you have a third variable, instead of mentioning it in the color argument, size argument, or shape argument, if you want to do as is study, you can put them in facet grid. Okay, this is a very useful tool. Finally, the theme structure, which is nothing but the variation of how your color, see the grid lines, the background color, the border lines, all those things come into the theme section. Plot background, strip background, legend, panel background, everything is a part of theme. Anything which is not related to the data is a part of theme. There are many examples of how the theme function keeps on modifying your chart. So whatever you see here has been basically described individually in the next slides. So if you just mention the GGPlot followed by the theme function, the first chart, that's what you get, as is plot object. I've just picked up this bar chart, okay? This bar chart that you saw here. I've just picked up this bar chart. If you just mention the theme function, this is the as is that you get. Inside the theme function, you mention panel grid. So basically all the lines, the grid lines that you see in the panel, that disappears. Element blank means you don't want that. Next, which is the third clockwise, if you mention the axis line, it will draw a bold line along the axis. You mention the panel background, it will disappear the color that's on the background. Okay, you can again keep modifying it. You mention the axis title .x, that means you want to specifically modify the axis title.x. This is the finest part of GGPlot. You can modify each and every object that gets plotted in the chart. Axis.title.x becomes red. Next, axis.title.y becomes red, and then the text becomes bold. Again, the actual axis structure, I mean, the figures, if they are not visible, I want to make it big, I want to make it bigger. So axis.text, you put those things in element text. Individually it sounds a little bit confusing, a lot of functions, a lot of abbreviations to remember. But once you keep doing 4, 5, 6, 8 charts, it becomes easy. Okay. Next is the legend position. You can put them in horizontal or vertical method. This is how you go. Okay, so these are all charts, nothing to talk about. The code is mentioned in every slide, but wherever you don't see the code, that's been mentioned at the notes section. Keep doing, please keep practicing them after you install the GGPlot package. All the data sets are open. They come readily available once you install the package. Nothing that you need to create, nothing that you need to modify, except the way that you want to look at it. Next is, it is an Obama staff salaries dataset. It's available in the open platform. This dataset contains the salaries of the staff at White House during Obama's presidency. Okay, so you have the dataset available in Excel format. We will import the dataset in Excel format. These are the questions that we want to answer from this case study. What's the trend of the salary, basic statistical inference, a year-on-year increment percentage? How can we visualize the percentage? You have the data set available. You can make your own question. You can try to answer it on your own way. So this slide talks about how you select the directory, how you install a package. This slide talks about how you use the read.xlsx function to read the Excel dataset. You just need to mention the path of the file, the name of the sheet, and the column headers. This slide talks about the dimensions, how you can use the dimension, study the dimension. You can use the in-row function, the names function, the dim function, the structure function, to first understand what exactly has gone inside R, whether the import is successful, whether there is anything you need to modify in the import function, whether all the data sets are fine, is how many missing values are there, what's the structure of the data set, is name a character variable, is salary a character variable or a numeric variable, what exactly you have imported. These are very good, useful function that you can use on the data sets that you have already inside the package, like empty cards, diamond, iris, or you can use them in your personal data sets as well. Finally, this is what do we infer from the chart. The code is mentioned in the notes section. So you can see that the green color is of employee. The red color is of detailee. And the blue color is of a part-time category. So there are 3 categories of employees that we have in the data. Okay, detailee, employee, part-time. The number of employees are obviously very distinctively higher than detailee and part-time. Obviously, part-time makes sense, but detailee, I think they are more expert. Why they are more expert? Because you can see that every year the salary of detailee is way higher than the employees. Okay, so obviously we can infer that detailee are more expert people. They give specialized, they do specialized jobs compared to employees, basically, the regular employees. And obviously the salary of employees ranges from high to low. Okay, the y-axis is the year, the y-axis is the salary, x-axis is the year. Finally, I want to know the median salary of each group by year. So every data y-axis is a year. Sorry, I take that back. The y-axis is the median salary. The x-axis is the year. and each color is the color of status. So you can see that our inference was right, that the median salary of detailee is way higher than the employee of the part-time, whereas the median salary of employee is way higher than the part-time. This is how it goes on increasing. First part-time employee, then detailee. Detailee are good, should be more experienced and specialized in their jobs. Okay, so this is one inference we can get. Next, I wanted to ask whether we can calculate the increment percentage of salaries for specifically to employees, the green in color. So what I did is I ran a piece of code wherein I calculated how many number of employees we have from year to year. So we can see from 2009 to 2010, we have 324 employees which qualify for an increment. So those employees were there in 2009 as well as 2010. Otherwise, I cannot calculate the increment, right? Same goes for 2010 to 11, but I have very low number of people in the data set. Whereas in 2015 to 16, same people, there are 312 people who got the increment. Okay, so what's the actual increment rate? Okay, percentage of annual increase in salary. So I can see that 2009 was around 0.67, whereas it way moved to around more than 100% to 2015-16. So the increment percentage is kept on increasing. Although we see a dip in 2010-11, which is 0.15, but I think that's a bad data point. We can't compare the increment based on only 7 employees. We would actually need a minimum of 30 employees to calculate anything, which we have in 2011-12. We have more than 30, 51, so, and the percentage is 0.39 for 2011-12. So except 2010-11, I think the percentage of annual increment kept on increasing. So this is the final slide at Techcanvass. These are the different categories of courses. We have a data science course with R, 32 hours. Big data analytics course for Hadoop and Spark, that's for 36 hours. Data visualization course with Tableau and ClickView, especially, that's for 28 hours. Data science course with MS Excel, that's for 20 hours. We do have an early bird discount for data science course, especially with Revolution R. Please do keep in touch with Nazneen or the Techcanvass office so that you can avail this discount. I still have 25 minutes of today's discussion. I'll leave it onto the audience so that they can ask their doubts. If you have any question, please go ahead and ask. I see only 2 participants, Reshma and Sunil. So if you do have any question, please go ahead and ask. Or else you have the material available with Nazneen or Shivangi. You can take that material, install R, install GG package, and keep practicing. Okay, shall I assume that we don't have any questions so far? Reshma, Shivang, Sunil? Okay, well, welcome. Sunil, can I hear from Reshma as well. I mean, if you don't have a mic, you can type. Like Sunil. If you don't have any question and if you're interested in this topic of GGPlot, please do take the material from Techcanvass and ensure you do come back if you have any question. All the basic stuff has been already put. Oh, welcome, Reshma. Thank you. It was quick.
I think so. There are no questions. So, any query apart from this, we have a contact number shared on the chat box with our website. You can do visit the website, guys, and you can contact us at any moment. We'll be there to help you out. And thank you for such a lovely audience. Thank you so much, sir, for sharing us such an informative thing. Thank you, everyone.
Thank you.
Thank
you. Bye-bye.
Bye.